All right. I'm only going to go over section 1, which is going to be the FRQ part. And remember, if you know how to do this section right here for the test review, then you know how to do the test essentially. Remember, all we're doing here is changing some numbers and calling it a day. So looking at number 1 here, we are given a polynomial. F of x is equal to ax cubed plus bx squared minus 16x minus 4. And when f of x is divided by x plus 1, our remainder is 4. It is also known that x is equal to 1 is a 0 of the function, and we want to determine the values of a and b. Now remember, I know that it's been a while since we had the snow days and whatnot, but we are using the remainder theorem here. So essentially, this is saying if f of x is divided by x plus 1, I'm going to have f of negative 1, and since my remainder is 4, I'm going to have an output value of 4. And if we know that f of 1 is a 0, then I know that f of 1 is going to be equal to 0. I'm going to use substitution here. So anytime I see a negative 1, or anytime I see an x, I'm going to substitute n with a negative 1. So I'm going to have a negative 1 cubed plus b negative 1 squared minus 16 negative 1 minus 4. And that has to equal positive 4, aka that is my remainder here. Likewise, if I have f of 1 is equal to 0, then I'm going to have a 1 cubed plus b 1 squared minus 16 times 1 minus 4 is equal to 0. Now, we'll probably have to go ahead and make this prettier by simplifying. So I'm going to go ahead and simplify the first one. And that is going to give me negative a plus b plus 16 minus 4 is equal to 4. And if I simplify that even more, I'm going to have negative a plus b. Let's see, this is 12, so I'm going to subtract 12 from 4. So that's going to give me a negative 8 right here. Likewise, for my second part, I'm going to have a plus b minus 16 minus 4 is equal to 0. That's a minus 20, and if I move that to the right side, I'm going to have a plus b is equal to 20. Now, just like what we did whenever we did this lesson right here, we are going to either use substitution, elimination, whatever you prefer. I'm going to use elimination here because it's going to be easy for me, because I could just add and get 2b is equal to 12, which means that the value of b has to be 6. And if b is 6, then by default, plugging into either the top one or the bottom one right here, I'm just going to get 14 as my a value. All right, number 2 is exactly what we did on Friday before the Desmos activity, where we looked at the graph and we know that this is negative 2 and we know that this is 3. Now, if I were to write this as a function, I'm going to have g of x is equal to some a value, aka the coefficient that we don't know. We have x plus 2 cubed because it's a wiggle. And then we also have x minus 3 squared because that is a bounce. Now, we also know that g of negative 3 is 9. So once again, anytime I see an x, I'm going to substitute that with a negative 3. And that is going to be equal to a y value of 9. So now I have 9 is equal to a negative 3 plus 2 cubed, negative 3 minus 3 squared. 9 is equal to negative 1 cubed, negative 6 squared, which gives me 9 is equal to a times negative 1 times 36, which gives me an a value of negative 9 over 36, or negative 1/4 if I were to simplify this. So negative 1/4 represents my coefficient. Now the question is asking us to find g of x. So once again, this is g of x. All I have to do now is just substitute in negative 1/4 into my a value and call it a day. So my final answer for number 2 is g of x is equal to negative 1/4 x plus 2 cubed x minus 3 squared. Which should make sense because guess what? This is an odd degree polynomial because my end behaviors are going opposite directions. And we also know that because as x is approaching negative infinity, y is approaching positive infinity, which means that we have a negative leading coefficient there. So that is number 2. Okay, now, number 3, you probably looked at this and thought, oh, it's very similar to the Unit 1 FRQ, because it is. And guess what? All we have to do now is just do the same process all over again. Remember that your tests are cumulative, so you are going to see a couple of things from piecewise functions on tomorrow's test, given that you do watch this on Monday. All right, so we are given p of x, and we want to evaluate to negative 4 p of 4 plus 2 times p of negative 1. Should all steps used to get your answer. The first thing that I'm going to do is probably figure out what p of 4 is. And that means I have to use my second subfunction, because 4 is greater than 2. Which gives me a value of negative 5. And then if I were to do p of negative 1, I'm going to use my first subfunction because negative 1 is less than or equal to 2. So that's going to give me negative 5 minus 6, or negative 11. Now, I have negative 4. I also know that p of 4 is negative 5. I have 2, and I also know that p of negative 1 is negative 11. So if I were to simplify that down, I'm going to have 20. And then I'm going to have negative 22, which gives me a final answer of negative 2. So this expression right here is evaluated to be negative 2. All right, 4a. We are given the polynomial h of x is equal to that lovely thing right here, and we want to find the degree of h. Well, if I were to look at the degree of h, notice how this is in standard form, so I'm just looking at the highest degree. In this case, that's going to be 5. Do not get mixed up with adding all of the exponents. You only add the exponents if we were to hypothetically say that this was all multiplied. If all of this were being multiplied together, then yes, you would multiply to get the degree. But because we have 3 different terms and it's in standard form, just look for the highest degree, 5. All right, 4b, describe the end behavior for h of x. You'll notice 2 things. It's an odd degree that we saw from part A, and we also know that this is a negative leading coefficient. Since we have an odd degree and a negative leading coefficient, this tells us that our end behavior is going to look something like this right here. So this is me saying as x approaches negative infinity, h of x is going to approach positive infinity. So this is saying as we are going to the left, our y value is going up. And then as we are going to the right, as x approaches infinity, our y value is going down, which means that h of x will approach negative infinity. All right, so for 4c, we want to find the y-intercept of h of x. Notice how, once again, this is in standard form. So we are just looking at the constant. But since there's not a constant, our y-intercept is going to be 0, 0. On the test, please make sure that whenever you're writing this, write it as a coordinate. Do not write it as 0 and call it a day. Y-intercept, coordinate, 0, 0. All right. Part D says factor h of x. I'm going to factor that. You'll notice that we have a GCF of x to the third because all of my terms here has an x to the third. And because I kind of want my leading coefficient to be positive, I'm going to take out a negative x to the third, which is going to give me x squared plus 9x minus 18. Okay, now, based off of this information, I'm not done yet because this is not fully factored. So I'm going to do negative x cubed and then factor out the x squared plus 9x minus 18. Plus 9x minus 18. So I'm going to try and figure out factors of negative 18. That's going to give me a net. Oops, just kidding, sorry. Since I factored out a negative, this should be a negative and this should be a positive. Yeah, that's good. I'm trying to find factors of 18. That's going to give me a sum of negative 9. And that is going to be negative 6 and negative 3. So I get negative x cubed, x minus 6, and x minus 3 for part D. Now for part E, I want to find my zeros and I want to state my multiplicity here. So looking at each factor here, I have a 0 at 0 because x cubed, that's just going to be 0. And my multiplicity is going to be whatever my degree is. That is going to be 3. I have another 0 at 6. And because my degree is 1, this tells me that I have a multiplicity of 1. And another one right here at 3. That's going to give me a multiplicity of 1. All right, 4F says to sketch h of x, your sketch should include proper end behavior, number of turns, y-intercept, zeros, and multiplicity. Now, we haven't really talked about turns, but remember that because we have a degree of 5, the maximum amount of turns that we should have is 4. Now, theoretically, it could be 3. Theoretically, it could be 2. Theoretically, it could be 1. Who knows? So we just got to see for 4F that it just has to be less than 1 less than the degrees. So it has to be at most 4. But if I were to look at this, I have 0, positive 3, and positive 6. My end behaviors are going opposite directions because it's odd and a negative leading coefficient. So at this point, we are just going to play connect the dots or connect all of the relationships that we have. I'm going to start with my end behavior right here, and I'm going to move all the way down until I hit my first 0. Now, once I hit my first 0, remember that because this is a multiplicity of 3, this should look like a snake or a wiggle. So on the test tomorrow, please make sure that your 0 at 0 is a snake at 0, something like that. Then we're going to go up to 3, and that is going to give me a multiplicity of 1, so that's just a cross. And then we're going to go down to 6, and that's just going to be another cross. And that gives us my final graph for h of x. You'll notice that here that we don't necessarily have 4 turns. We have 1 turn right here, 1 turn right here, a turn right here, and another turn right here. So about 3 turns or so, or 4. Yeah, we actually have 4 turns, so that's good. Yeah. 1, 2, 3, 4. 1, 2, 3, 4. Yeah, so we actually do have 4 turns, which is good. All right, last one. For G, we want to use long division to divide this expression out. Now, h of x, remember, is the original function that we had, which, if you remembered from the front page, was negative x to the fifth plus 9x to the fourth minus 18x to the third. And I'm going to divide that by x to the fourth, negative x to the fourth plus 3x to the third. All right, so if I were to look at this, what times negative x to the fourth will give me a negative x to the fifth? And that's just going to be 1x. So I'm going to put that, I guess, right here. Usually I put it with its respective column, but since it's 0x right here, I'll just put it right here for the sake of it. I have 1x, so I'm going to have negative x to the fifth. And then I'm going to multiply x and 3x to the third, which gives me 3x to the fourth. I'm going to subtract, and remember, subtracting is the same thing as adding my opposites. So if I subtract, negative x to the fifth minus negative x to the fifth would be negative x to the fifth plus x to the fifth, which should give me 0 because I want that to be canceled out. And then 9x to the fourth minus 3x to the fourth is going to be 6x to the fourth. And then we have negative 18x to the third. All right, so now we're going to look at 6x to the fourth, and we are going to look at that in relation to negative x to the fourth. So we need to figure out what times negative x to the fourth will give me 6x to the fourth. That is going to be a minus 6. And that is going to give me negative 6 times negative x to the fourth, which is 6x to the fourth, negative 6 times 3x to the third, which is negative 18x to the third. And surprisingly, if you did that, I am left with a remainder of 0, which means that your answer for 4G is going to be x minus 6. Now, as a little hint, if you're watching this, on the test, you will not have a remainder, meaning that you should have a pretty answer in terms of your quotient right here. So that is basically it for section 1, aka your FRQ part. So you should be good with the FRQ there. FRQ is worth 40 points, and then MCQ is worth 60. Section 2, like I said earlier, is very similar to what you'll see on the MCQ portion. I'm not going to go over these examples right here, but I will post a key so you have access to it.